Okay. Hi, I'm Amy. I'm an industrial engineer by trade, by degree and by trade, since I graduated. So that's mostly what I'm going to focus on in this presentation, is a little bit more in depth of what industrial engineering is. Andrew kind of gave you a broad overview of like the different engineerings and how to go to school for it, and this is kind of more in depth of just specifically about industrial and manufacturing engineering, which essentially are the same things. So you can click to the next slide. So I'll start with my background. So I was born and raised in Wisconsin. So I went to University of Wisconsin-Madison for my undergrad, graduated in 2004, same as Andrew. While I was in my undergrad, I interned with Intel in California, which essentially is how I got my in the end, my official job offer. So I interned with them. When I graduated from my undergrad, they hired me on full-time into that same group I interned with. While I was at Intel in Santa Clara, I got my master's part-time while working. So University of Wisconsin-Madison had a really good online program. They have like an engineering professional development department within the College of Engineering, that typically when you're in your undergrad there does like all the communication classes and written and verbal and that sort of stuff. But they have this great engineering management program, which is all online, so you can do it from anywhere. So I had classmates all over the world, and classmates that traveled for their jobs, so it's a good way if you wanted to get an advanced degree, but you currently traveled for work or you didn't live in Wisconsin, you can do it online. So I got that in 2011, and then shortly thereafter, I got a new job at Intel and transferred up here to Oregon in 2012. Still, in both cases at Intel, essentially my job title is an industrial engineer. So my entire, almost now 15 years at Intel is all completely industrial engineering. So I actually apply everything I learned in school to my job, which most people can't say, I don't think, anymore these days. But obviously it was the right career choice for me because I still enjoy it, like I'm still doing it. So I obviously enjoy it. Okay, so next slide is like, how did I decide to become an industrial engineer? So for anyone who's not sure what they want to do, I was in that same boat when I graduated high school. I knew I was good at math and science, but like I didn't know how to apply that. And I did not have like an engineering program. I didn't have like the class that Andrew teaches in the evening to teach me anything about engineering. So I like actually didn't even know engineering existed before almost graduating from high school. Fortunately, my grandfather was an electrical engineer, so he one day was just like, hey, you like math and science, you should really look into engineering. Whereas I was more like, I think I'll just go into business and maybe do like accounting or finance or actuarial science, like something that deals with numbers. But all those ones are kind of like you're just by yourself in a room dealing with numbers, and that's also not necessarily my personality. So I didn't know if I'd really like that. So my first semester, or actually I think it was in the spring semester of my freshman year in college, I took like an intro to engineering class, which essentially was a 1 credit that I had to pay for. I sat in it, you really just had to go. They brought in like an industry professional of each engineering type and essentially told you what they did, really, right? So out of that I walked away with, okay, biomedical sounds pretty cool. I thought about being a doctor at one point, so like, let's look into that one. So I went and saw my college counselor, and he gave me a professor to talk to about biomedical, but then he kept giving me all this information about industrial engineering. And I was like, why is he giving me this? Right, like you're a student, I came here not to talk about that. Like, why are you giving me this information I'm not asking for? Right, so luckily I kept it, took it back with me. I met with the biomedical professor and it was not what I wanted it to be. I was gonna be in a lab all the time, like dealing with specimens, and also not my cup of tea. So I was very much diverging between business and engineering. So at that point I was like, pre-business, here we go. I was packing up to go back to college sophomore year, going through all my stuff, and I happened to keep that industrial engineering information the counselor gave me. Started paging through it, and I was like, wow, this actually could be perfect. Because industrial engineering is very much like the business side of engineering. You have to take like accounting, economics, you have to work on return on investments, so it kind of blends the two together. You get the engineering problem-solving mindset, but you get to deal with all the business people and look at the holistic picture of everything. Is kind of your job. So it ended up being a great fit for me, but it was really random kind of how I got there. So now we'll kind of go into that long-winded story of how I picked it, into really what is industrial engineering. Industrial and manufacturing engineering is, simply put, efficiency. Your entire job is to make processes, services, everything more efficient, to save the company money, save people time, all of that. Like, essentially, like, what company doesn't want to save money? So that's your entire role, pretty much, is to come up with new ways to save money. So this continuous improvement cycle goes right along with industrial engineering. It's essentially what it is. So the first step is you have to identify the problems, right? So you're looking in to figure out what's going on. So you really have to dig into the actual, what's the current process today, and then look for inefficiencies within that process, right? Once you've figured out where those inefficiencies are, then you plan how to fix them. What can you implement, what can you change to make it better, right? Once you decide on that, you have to look at all those different options to say, well, what really can we do and what can't we do, right? There's always options to automate things, to spend a ton of money to get something fixed, but that might not be what the company can afford. So you have to look at the options realistically of what can you do realistically to solve the problem, or at least what can you do today to make it better. Right, so then you pick those and then you execute them essentially. So you implement them in. You then have to re-review what you just implemented to make sure that it didn't cause a problem anyplace else. Right, so that's one of the things, an IE has to look at the holistic large picture of everything going on. Because if you're going in to fix just one small problem, you might actually cause another problem in another part of the process. So that's where the review comes in, and then you say, oh, oops, I did this and it didn't work out, so we need to make these modifications, and you kind of start the cycle all over again, right? So essentially, you can click the button. Industrial engineering is problem solving with optimization in mind. So like Andrew said, industrial engineering or engineering in general, is solving problems. Industrial engineering is kind of solving process-related problems and just trying to optimize everything. So, oh my gosh, my mouth is super dry. Okay, so to illustrate kind of industrial engineering, we're gonna go through a problem with props. Okay. So our process is going to be sorting mini candy bars. So we have a giant bag of mini candy bars, 5 different types. We're going to create a virtual process line of how we would go about sorting them. So there's going to be 4 steps in the process. That's how it's going to work. Station 1 is going to be tasked with opening the bag, walking over to Station 2, and emptying the contents onto Station 2. Station 2 is going to be the sort station. So that person's going to take the random bag of all the different types of candy bars and sort them into these are the Milky Ways, these are the Snickers, these are the Three Musketeers, and so on. Station 3 is then going to walk over to Station 1, grab one type of candy bar, carry it back to Station 3, and then sort them into individual cups with only 5 in each cup. So then so why they can only pick up one candy bar is because quality has to be involved, right? You can't have cross-contamination between different types of candy bars. So that's why they have to carry only one at a time. Station 4 is the final station, that's the shipping station. Station 4 is going to walk over to Station 3 and take one candy type at a time, the cups, carry them from Station 3 back to the shipping area in Station 4. So if you click a couple times, there'll be a couple arrows. Station 1 to Station 2, Station 2 to Station 3, Station 3 to Station 4. You can kind of see some inefficiencies already. Right. Okay, so next slide. All right, so where do you start? Right, first you have to identify where the inefficiencies. So one of the most basic industrial engineering activities is time studies. Super fun. You will make all of your interns do it. Because after you're an intern, you don't want to do it anymore. I had to do it through both of my internships. But it's the best way to really understand what's going on in the process, right? And nowadays there's better. I've had interns that now have a computer program that easily much more calculates their times and everything. I used to have to actually go in with a stopwatch and a piece of clean room paper and write down the times and then plug it into Excel and do it all that way, right? So there's much more efficient ways to do it now. But the best way to do it, or the best thing to do, is the time studies, because you also get to observe what's going on around you, right? And see like exactly how they're doing everything that they're doing, right? So you end up breaking down each step even farther than what I simply said of, okay, number 1 is he opens the bag and then he walks it over to Station 2 and dumps it out, right? So you want to break down step 1 into all of its kind of sub-steps. So let's say it takes 2 minutes to open the bag and then walk the stuff over, dump it out, and then walk back to Station 1, right? It's 30 seconds to open the bag. It's 45 seconds to walk from Station 1 to Station 2, and then 45 seconds to walk back from Station 2 back to his Station 1 to get his next bag, to open it up and do it again, right? So that's the breakdown of step 1. Next slide. Step 2, let's say it takes 5 minutes total to sort all the candy bars into their subsequent little bundles of each type, right? So it takes, on average, 1 minute per candy type, right? So this is where, because this is a super manual process, you would have to time each one of the different people that works that station and see, like, on average, how long does it take them to do it, right? To really kind of determine an overall process, like an overall time. So then step 3 takes a lot more time. Oh, can you hit one more time? I didn't get my animation correct. So step 3 takes a lot more time, it takes 10 minutes. Because the person at Station 2 is literally just standing at their station the whole time just sorting candy. Station 3 has to walk to Station 2 to pick up just one type of candy, walk back, put it into the cups, walk back over to grab the next kind of candy, put it in the cups. So let's say they're much closer together, so it only takes him 15 seconds to walk back and forth, but because there's 5 different types of candy in each bag, he has to walk back and forth 10 times. So it takes him 2.5 minutes per bag. Plus then it takes him 1.5 minutes to sort the different types of candies into the 5 in each cup, right? So then step 4 is pretty much easier. He just has to walk back and forth. He walks over from his station to Station 3 to pick up one type of candy and walks back, then walks back again and walks back. So, and like I said, he can only take one type of candy at a time because we don't want any cross-contamination, right? You can't mix the candies after they've been sorted. And they don't have a way right now to transport it without mixing it. So, with that in mind, does anybody have any ideas of ways to maybe make this more efficient?
Put it in order 1, 2, 3, 4, and put the desks sideways right next to each other so it's not too crowded.
Oh yeah, that's good. That's good. I didn't have that idea of turning the tables when I did this presentation. Any other options?
You can shorten the distance between 4 and 3.
Yep.
You could do each step to like have equal amount of steps and equal amount of time.
Yep. That will make everything optimized and flow smoothly. Yep.
You could have like robots deliver those from like 3 to 4 instead
Yep.
of like having a person have to do it themselves.
Yep. That's the automation aspect. All right, those are really good. I think I got most of them, not all of them in my presentation. Okay, so I've categorized them into different types of improvement projects, right? So you have your layout projects. So that's relocating the stations to go in order, right? Moving 1, 2, 3 closer to station 4. Your capacity projects are removing your bottlenecks. So that's essentially where the second and third step took longer than the predecessor step. So that means they're going to build up inventory at their station. They can't keep up, right? Like the inventory is coming in quicker than they can get it out. So those are essentially your what we call bottlenecks as an industrial engineer. So you want to remove those as much as you can, which could be adding additional stations. You could add extra headcount, so forth. You could also, between station 3 and 4, you could design some sort of carrier, like a cart, so he can take more than one candy type without having to go back and forth, and then they won't cross-contaminate. There could be like different pockets for each different candy type, right? Or you can go the more expensive route of automation projects. So this is my idea of adding a conveyor belt between them. Turning the tables is probably a better idea. Be cheaper. But that would eliminate walking between all the stations for sure. Or you can add robots and or machinery to essentially take out that human error option and quality control. So it would reduce the risk of potentially the sorting being missed, somebody did something wrong, and just ensure that the quality is good because the machine will always follow its program, right? As well as could potentially do it faster. All right, so with all that stuff, next slide, we incorporate some of that in. So now we're in the implementation stage, right? So what I decided to do was I ordered it, but one constraint was we couldn't move these 3 closer to shipping. So that was a no-go. There's other stuff in between there, and it would just cost too much to shift everything all the way over closer to shipping, right? So what we did, we still have person number 1 here, but now they don't have to walk 45 seconds, they only have to walk 15 seconds to number 2. So it cuts him down from 2 minutes to 1 minute, right? So he's already more efficient. Then I added a robot to station 2 because he can sort a lot faster than a person. So this robot can sort a whole bag of candy in 2 minutes, right? For station 3, I gave him a cart so he could take more than one type of candy at a time from the sort station. So he could go over and take a whole bag sorted separately over to his and then just pop it into the different cups. Right? And then I added, this is supposed to be a conveyor belt, between 3 and 4. So now 4 doesn't have to walk anymore. He just has to pick stuff off the conveyor belt and put it into its respective shipping thing. So let's say that takes him a minute now, right? So still not totally optimized, right? Does anybody see a big bottleneck?
Station 3 takes 6 minutes, whereas one before takes 2, so there'd be a lot of build up there.
Right. Yep. Yeah, and what we're going to say about this guy is we want him to be our constraint because those robots are expensive. Those sorting machines are really expensive. The company can only buy one. So we want to make this station our constraint. We want to do everything we can to make that the constraint, right? So one reason why I didn't put a conveyor right here is if you remember at the beginning, it takes him only 30 seconds to open a bag. And if all you had to do is open it, dump it on the conveyor, and that took it right to the robot would be super constrained, right? So it didn't make sense for me to spend the money to add a conveyor belt in this first part because it would have just added to the constraint on the robot, right? But we can get rid of, we do want to get rid of this one. Because that one's just people in a cart. It's not that expensive. So you want to click to the next slide. So now what I did was I added 2 more, right? So now it's 6 minutes for each one of them to do their thing, but one of them can come every 2 minutes to pick up more supply from the sorting robot. So now there shouldn't be any wait between the robot and station 3 anymore, right? And then they all just filter on the conveyor belt and go to person number 4, and he sends it on its way. Right, so that kind of like, in a nutshell, is a very basic example of industrial engineering and what we do. As you do it longer, like I've been doing it for a really long time, you get really cool projects that have a lot more constraints and a lot more process steps than this. So, for example, Intel semiconductor manufacturing has thousands of steps. We have probably about 500 pieces of equipment throughout the entire process. And now we run multiple technologies at one time that can't share. Some can share equipment, some can't share equipment. So I get to own all of that and determine what is the best mix of technologies we should produce here in Oregon. Right, so I get to meet with high-up VPs and say, hey, this is how much you're going to have to spend in order to increase our wafer starts by 1,000, by 500, and exactly what you'd have to buy to get there. So, which is pretty impactful for Intel, because semiconductor manufacturing is also very expensive. So, so it's good. But next slide, I forget what's on there. Okay. All right, so there's multiple different kinds of engineering career options out there. The one I highlighted is mostly like a manufacturing type of engineering, industrial engineering. But you can house on a lot of different facets. So I've done actually almost all of these different types throughout my career at Intel, just being an industrial engineer there. So currently I do capacity planning. That's what is kind of meant by the number of how much manufacturing equipment Intel needs. So how much they need here as well as how much they need worldwide to meet the demand. Layout and factory design, we saw that in shifting around those workstations. My team here in Oregon also owns all of the factory. My job in California, I pretty much solely did layout. So I owned the entire manufacturing facility down in Santa Clara, meaning no one could put anything in that factory without me approving it. So I put all the equipment where it needed to go. I put all the workstations where they needed to go, garbage cans, whip racks. Anything and everything that would go in the factory had to get my approval before it could go in, which is cool. And then you get to design new buildings too. So we also expanded, so I got to design a whole new factory site in like what we call a green space, which is a brand new empty factory or like fab building, which is pretty cool. You learn a lot from that. Human factors and ergonomics. That's kind of like, it goes a lot with workstation design and safety. Essentially, it's ensuring that there's enough space for people to do the job that they need to, and you're doing it in the right posture. So when you're standing, working at a computer, your arms should be at 90 degrees. When you're sitting, should be the same thing. When you'd be working at one of those workstations, you want to make sure that the height is equivalent for someone standing there working all day, so you're not like this. Right? That's going to cause problems for your workers, and then that's going to decrease their productivity, which is going to hurt your bottom line. Right? So that's another facet you can specialize in through industrial engineering. Risk analysis and decision making. I have a girlfriend from college, graduated with an industrial engineering degree. She's been working for an insurance company ever since she graduated, doing essentially risk analysis for them. So she goes out and checks on the buildings or whatever that people want to insure with them, and she decides whether it's a good risk option for the company or not. It's another thing you can do as an industrial engineer. And of course, quality control, right? Along with the candy, You want to make sure you're not contaminating things, mixing things up. So you want to make sure that you're producing quality products in the end. Right? So the next slide has just some random companies. There's a lot more than this, obviously. I just tried to get kind of like a random spectrum of all the different types of companies that hire industrial engineers. So Amazon's big if you're an industrial engineer, if you want to work for Amazon. Doing their warehouse designs, doing their logistics between where do they build a warehouse, where should they have warehouses, where should their distribution, like how should their distribution work? Like someone orders something in California, like should it come from the Oregon warehouse or should it come from the Nevada warehouse? Like all the logistics between all of that and the inventory storage, how big does their warehouses need to be? How much supply should they have on hand at any one time? All that stuff is very much industrial engineering based. Tesla is a manufacturing company. Any car company, any manufacturing company in general really likes industrial engineers. All of those things you hear about Lean, Six Sigma, it's all industrial engineering. Apple, of course. Miller Brewing, you could work for a brewing company. I actually applied to be an intern there when I lived in Wisconsin. You would have been able to taste beer because as part of your job is quality control at Miller, so you have to make sure that the beer always tastes consistently the same through every batch. If you like beer, or will like beer, not that you're drinking today. Mars, the candy company. UPS, kind of the same as Amazon. They want to know like where they should send their trucks, like how should they fill the trucks with packages in order to distribute them using the least amount of gas, using the least amount of trucks, like being the most efficient. Healthcare is also another big one. Healthcare needs a lot of efficiency help most of the time through pharmaceuticals, through just how nurses are used on the floor, how many nurses they need on staff at any one time. If you go into industrial engineering, there'll be a lot of healthcare projects for you to do if you're interested in that. Nike, of course, they produce shoes and clothing. Yeah, you get kind of the gist. This is the insurance company that my girlfriend works for and has forever. So they can use industrial engineers. How am I doing on time? Good. One last slide. So just I guess there's actually two. I can be quick. So what's different about industrial engineering than other engineering courses? You're going to take a lot more statistics. You take accounting, you take economics, you take more communication courses. Because as an industrial engineer, like in that process flow example, you have to work with all those people to decide how things are going. You have to work with them on implementing a new solution. You work with a lot of people. You're very much like a support person. So you have to have good communication skills, right? That's why I got my minor in technical communication along with my undergrad degree. But then the last slide, I think, is why you should be an industrial engineer. So if you enjoy making things better, problem solving, working with other people, you like to organize things, save time and money, you could probably be a good industrial engineer. I think about it all the time. Like everything I do, I try to do it better the next time I do it. Just kind of how my mind works, which was why this was a good fit for me. But yeah, with that, I don't have anything else to discuss. So if anyone has any questions, go for it.
Trial and error, would you say, is involved?
A fair amount. So that's a good question, actually. So industrial engineering is like, it is a lot of trial and error, but you do it, you want to do like risk-based decision making. I can't open that. So you want to like, with the best information you have, make the best decision, right? So I have to keep holding this. I'm going to be out of stuff. Tricks. So you want to make the best decision with the knowledge that you know at the time, right? But it is very much like kind of trial and error. And as you do more, you learn. Like, because you learn from mistakes. That's the biggest thing of being an industrial engineer. If you make a mistake, learn something from it so you know not to do it again.
If you could go back and like be a different engineer, what would you be?
Ooh, I don't know that I would be one, but my second, like the closest thing would probably be a civil engineer. Who had a hand up for a while? Yes.
If you weren't in
Oops, sorry.
what would you work on instead?
I don't know. Now, yeah, I considered applying for a job at Nike a little while ago. I feel like now after being at Intel, it would be really hard for me to go anywhere else because the manufacturing processes for everything else is so much simpler.
And also, do you have a day shift or either night? Because my dad has night shifts a lot.
I work normal day shift. So 8 to 5, Monday through Friday. You want a candy? See if I can get it there. Oh, not quite. Go for it. It does. It does a few. It's added more since I went to school, but it does. We actually do need, because we do so much like in Excel and like calculations are getting so much more complicated that a lot of the IEs we hire in now do have like better programming skills, so we can actually do like create systems and databases. It was better. I was like,
So if you were a high school student today and like you could change your career or what you would do, what would you change?
like do something totally different.
No, like, let's say you still wanted to be an industrial engineer, but like what would you have done differently?
That's a good question. Let's see, what would I have done differently? It's hard to say, because like I'm so used to the path I got. Man, I don't know. I'll have to think about it. If I come up with it before we're done with questions and answers, I'll answer that. Way in the back.
So for any student wanting to enter the field, what's the number one most important advice that you would give them?
What I tell everybody, I mean, kind of this is sort of regardless of major, but is make sure you really enjoy what you're doing. So make sure you really enjoy the classes that you're taking and you're good at it, because that's just going to make your job that much easier, right? Like if you're struggling through the classes, then you may struggle then through your job. And the better you are at your job, the faster you get promoted, the faster you make more money, and the happier you are just because it's less stressful. So I would say, if anything, just find what like seems to be your niche, and like make it a career.
What's your favorite part about being
Making everything better. Simply put, like I hate inefficiency. It drives me crazy when I see people wasting time. So I always want to like push to make it better. Oh, sorry, I'm like behind. So, yeah. Oh, go for it.
What levels of math do you think you use in like your everyday job?
Not that much. In industrial engineering, you have to take, like I said, more statistics than any other engineering. So, because it is very like statistical based of like determining what's the best option, right, based on probability and so forth. So I probably use statistics more than calculus or any of the other math that I learned in school. Who haven't?
So for your classes that you took in college, what would you say like your hardest class is, and like how did you like come to the decision that you wanted to be like an industrial engineer?
Hardest class ever, physics. Which was also, so that's actually like a good lead-in question for something else. There is always going to be a weed-out class at every school, getting into any sort of college of business, college of engineering, whatever it is, whatever you want to go into. There's going to be some class that they're going to make ridiculously difficult, and everyone is almost going to be failing. That was physics at Wisconsin. So getting through, like, but you know that from other students, right? Going in, like, this is the weed-out class, so you know it's going to be rough, but you just have to push through and keep going because it gets way better after that. How I decided on industrial engineering was really the, like, business aspect to it. So it really still was like, okay, I'm going to get to talk to the business side and like the dollar side, but I can speak like an engineer. So industrial engineers are also very prone to go into management type positions. So project management, program management, just managing of people in general, because you do kind of get trained for that, so you can understand the technical side, but you can speak to the business side. So, who haven't I called on yet?
I'm thinking for a parent's voice, I feel like I just want to do something more timeless for myself. So I find it's a question inside me.
Yeah.
Yeah.
Yeah. Oh, sorry. Getting things going. Oop. Nope. Okay. I don't know how many more. Maybe just one more question after this. Ooh.
How influential do you think your internship was in like choosing your career?
Great question. My internship was, I think, critical to determining if I really liked the career or not. It really gave me a good taste of what it was going to be like to be an industrial engineer, and if I would enjoy it. Like a good example, my brother thought that he was going to do like graphics design when he was in college, was going to school specifically for that. He got an internship that they actually said, like, hey, just keep working here. He did it and hated it, so I ended up quitting, went back to school for business. So like, I think internships are a really good way to learn, first, if you like the career choice you're going into, and second, if you like that company, too. All right, last one.
Would you say that to be an industrial engineer, you have to have a fairly regimented lifestyle?
How do you mean by regimented?
I don't know, like heavily scheduled, maybe? I don't know.
I don't think so. Like, you probably would kind of organize yourself anyways, because if you're already going to be an industrial engineer, you're pretty, like, kind of regimented in, like your processes and like to do things a certain way or make it more efficient. So I don't think it's been overly, like it wouldn't be any more per se than any other engineering that you went into. And actually a lot of the other engineers call you imaginary engineers because they find your classes a lot easier than theirs. So I just used to say I wasn't stupid enough to take hard classes. So, all right, I think I'm probably out of time. But thanks.